Okay, moving on. We don't always have triangles when we talk about trigonometry. It's sometimes useful to think about angles in a circle in order to compute those trigonometric ratios. So what we're going to review now in section 4.1 is the two different ways to describe angles using degrees and radians to prep us for understanding how we can compute trig functions in a circle. Radians are the preferred angle measure in calculus, so you have to get comfortable with that measurement for the class after this. So to review, we can find the measure of any angle theta in a circle using the formula theta equals arc length over radius. So what we're going to do is look at a central angle, and we want to kind of understand how big a radian is. So we want to draw an angle on the circle here with radius r that creates an arc with the same length as the radius. So if you can visualize kind of this length here, I would like to create that same distance on the edge of the circle so that this arc length here is also r. And I'm going to call this central angle that I've created here theta. And so to understand how big a radian is, if I look at this very specific central angle I've chosen here, then the arc length is r, and the radius is r, and so this theta has a measure of 1 radian. So to kind of understand how many radians occur in each circle, let's think about what happens when we have a full circle. So we have to know from a previous course the formula for circumference of a circle. So the circumference of a circle is 2 pi r. So that means that if I chose to create an angle theta that started here and rotated all the way around the circle and came back to the original location, then the arc length that I've created is this entire circumference of the circle. So if I want to describe that in radians, then the arc length is the full circumference of the circle, 2 pi r, for the radius r that we chose. And so one rotation around a complete circle has an angle of 2 pi radians. Now pi is the same pi you've known before, 3.14. So if you put that into your calculator, 2 pi, or 2 times 3.14, is approximately 6.28. So that kind of helps you understand how big a radian is in terms of real numbers on the number line. So this fact is important because this is going to help us convert between radians and degrees. So you're probably more familiar with degrees, and you should know that one full rotation of a circle is 360 degrees. So it's true that 2 pi radians is equal to 360 degrees. And if instead I only went halfway around the circle, I'd create a straight angle, an angle that went straight across, and so pi radians are equal to 180 degrees. If you can remember this fact, you can convert between radians and degrees no problem. So when you're using your calculator, it's really important to double check what mode your calculator's in, because it can compute both in radians and in degrees, but it could give you very different answers depending on what mode you're in. So grab your calculator, and we're going to look at some examples in radian mode. So here's my calculator, and when I turn it on, I'm going to hit this mode button here, and I want to go down, and the third menu item here is radian or degree. So mine is in radians, but if it weren't, I would arrow over to the one that I wanted and hit enter. So once it's in radian mode, I can clear back out of it. And so what I want to do is compute the following in my calculator. The first one is sine 4. So you can find your sine button, 4 radians here. So it's not going to be a complete circle because a complete circle is 6.28 radians. But when I do that, I get the sine of that is negative 0.7568 if I round. Now you might notice that your calculator doesn't have a cosecant button. It only has sine, cosine, and tangent. So in order to compute a cosecant in your calculator, you need to actually type in 1 divided by sine of pi over 7, because you need to use the reciprocal property of cosecant. So to do that, I would type in 1 divided by sine, and then pi over 7 and close the parentheses. And that gives me 2.3048 if I round. And I'll have to do the same thing for cotangent. I don't have a cotangent button, so I need to type 1 divided by tan of 5 pi over 6 and see what that gives me. again, if I round, that'll give me negative 1.7321. Okay, so now it's time to switch modes because I'm going to do the next in degrees. So if I go back to my mode button, I'm going to come over and hit degree and then clear out of that screen. And so the first one wants me to do the sine of 50 degrees. That's going to give me 0.7660 if I round. And then again, moving on to do cosecant, my calculator doesn't have cosecant, so I would need to do 1 divided by sine of 50 degrees in order to get that value. 1.3054 if I round. And tangent is a button my calculator has, so I can just compute the last one, tangent of 210 exactly. And then if I round, 0.5774. So for the rest of chapter 4, it's going to be important that you notice whether or not the original problem's in degree or radians, and that you always double check that your calculator is in the correct mode.